if they put a bit of a lapse that they finished. Good. Can you all see the screen? Is it all up with you? You should be seeing a green slide. A487.
Yes, got that. Thanks.
Okay. Right. Okay then. Right. So what to do? If I can get the right place. Sorry about that. We start off in the middle, not the end. It's just been a bit difficult for me now. Sorry. Right. This scheme, the Dyfi Bridge, New Dyfi Bridge, is located in the Dyfi Valley, where the frequent flooding occurs in the winter on the trunk roads network. It's located between the old Dyfi Bridge to the north and the railway line just to the north of Machynlleth. As a result of then, this section of road is frequently closed. It can flood up to 7-8 times a year, obviously resulting in communities being cut off sometimes to 24 hours, up to three days during a flood event. It results into a diversion of 30 miles, and I'll explain in a minute the location. It's on a route from the north of the bridge, from the South Gwynedd area, quite a large geographical area, which runs to the nearest hospital in Aberystwyth. So the scheme itself is 1.2 kilometres long, but the viaduct is elevated over the floodplain. It's a 724-metre long viaduct, 20 spans. And obviously the idea of this scheme is to improve the resilience of this strategic trunk road route, one of the main sort of routes in North Wales, and to provide connectivity for education, healthcare, and the rest of it, right? So location is, again, in mid Wales. We've got the 487, which is one of the north to south Wales trunk roads. We've got the 470 in the middle and the 483 at the east. This runs up the west coast. It's the first crossing of the River Dyfi from the coastline, so you can see it's well back in from the coastline. And as I said, that serves quite a chunk of geographical area in South Gwynedd, which uses this bridge to obviously run south and use the hospital just here in Aberystwyth. So when this road is shut, it's quite a significant diversion around, nearly 30 miles around. Why are we doing it then? I said the road floods. That's the existing bridge, 120, well, sorry, nearly 200 years old now, or masonry arch bridge. Substandard, narrow, low parapets, gets regularly hit by vehicles. And again, it's closed for repairs, or if not, for these flooding. It's a listed structure, so you can't do much with it. It floods south of the job under the railway bridge there, which cuts off the town. That's just the north of Machynlleth. And you can see again from the other way, and you can see that second, the slide on the top right, the whole valley is inundated across from the railway bridge right across to the bridge on the other side of the valley. So scheme design, there was obviously, it went through the key stages of the development from Welsh Government. It's say the trunk road, just Welsh Government funded. This is the area, this is the railway line here. This is the Eco Park just north of Machynlleth. They looked at online improvements to the west, and improvements on the upstream to the east side of the existing road. These online and to the west were not appropriate. You couldn't get enough elevation. You ended up on a section of A road here, the A493, which is very substandard, would have required a lot of improvement to upgrade to trunk road. The two solutions on east were the preferred. The purpley route there would have ended up with a roundabout in very steep sidelong ground, would have meant massive earthworks and a roundabout. So the chosen scheme at key stage 2, if you like, was to actually take that route there from the 487 just north of the Eco Park and to drop back onto the line just north of the river. It was very prescriptive, the scheme requirements from the Welsh Government. Griffiths actually won this under an ECI contract, a early contractor involvement, to bring a contractor on board to design the job with a consultant, and hopefully end up with a good scheme. This drawing here, not a very good drawing unfortunately, but that is the scheme drawing we were given to price on at tender stage. And I say it showed this little sort of S-back route across the valley, north of the bridge with a link back to the existing road going to the west coast, Aberdyfian. and it was very prescriptive as with the way we were to do it. So that was the job we tendered on. We looked at the tender stage, what sort of structure would be best suited to crossing the valley, and we ended up with all these sort of matrix here. We chose a sort of complex construction with steel beams over reinforced concrete columns. One of our major solutions at tender stage was to straighten out the alignment and push launch the structure, because it's a very difficult site with the flooding, very poor ground conditions. So we thought we would actually push the structure out over the floodplain from one location on the south. We then would actually save all the wet trades. We would actually use precast units on the deck. So all the environmental pluses from that, quality issues, and reducing all the risk working in a floodplain. So what we actually did, that was the proposal at tender stage. The embankment was there, which was on that original drawing from the local Welsh government. We straightened out the alignment to allow this push launch landing north of the river at what we call Free Gate. We then took that through some design development, and the first thing we did was to model the flooding of the valley. This scheme was not appropriate or acceptable because you had a massive buildup of water behind this embankment, and you can see it's obvious it dams the floodplain, because the floodplain is right across from the river to the railway line. This flooding was unacceptable. It also rose the levels around the Dyfi Bridge itself, the old Dyfi Bridge, and probably would result in the bridge getting washed away. So we looked at extending the viaduct and various other measures to reduce these floodwaters. And the scheme we ended up with was 170 meters longer. So we took out the embankment, extended the south abutment right through to this location here at the edge of the eco park. So we'd extended by 100 centimeter with a curved section of viaduct with the original 550 meters there. So we ended up with a 720 odd long meter job. There was this embankment obviously to take this up to a level to get it above the water, flood water. And you can't see it well in this drawing, but there's also an embankment to be constructed around this eco park, where it's a little business park here, to protect it from the flooding, which it did flood part of this, flooded already during a flood event. So just give it 1 in 1,000 year protection. For my discussion, I'll be splitting the structure because I'm going to concentrate on the structure. So I'll be referring to the curved section, which is this south section here, roughly 170 meters long. The ladder or straight section for the middle, which is where we did the push launch. And then we'll refer to the river crossing, because this again was a different construction. Rather than a ladder deck, it was a multi-beam, because the spans were much larger, 50 meter and 75 meter span over the river. I'll be talking about those in there. So a part of the BIM model there, you've got the steel deck, you've got these reinforced concrete columns, and a pile foundation extending some 28-30 meters into the gravels below. You've got a pile foundation to the southern abutment. We land across the river onto a spread foundation at the north abutment here. We didn't put piles here. There was no rock found across the valley floor. We hit some rock right by the river at Pier 19, and there was rock underneath the north abutment, but it was quite poor quality. So that's the shape of the thing. We need to discuss a bit more detail, I suppose, of the structure itself. So we've got the 3 sections. This is the curved section where we've got these monopiles going down 30 meters through the 12 diameter, some 30 meters long through the gravels. Now, there's no pile cap here. The reason we tried to design out the pile cap was to reduce work in this very poor quality silt material. So we'd had cofferdams, which you'll see, which we had to put on 1 or 2 of them. Extensive sort of temporary works. So this was a monopile 12 diameter covered in a 2 meter reinforced concrete column with a ladder beam construction on top of it. It was the same through the main push launch, but then we go in over the river spans. We have these 4 bigger beams called the multi-girder, which span over 50 meters and 75 meters over the river. This proved to be very sort of environmentally and carbon saving, very friendly, because we reduced a lot of excavation, a lot of concrete, reinforced concrete, steel, etc., and much quicker, which you'll see from the photographs as I go through the presentation. So, as I said, it was an ECI process. We actually won this contract in 2015. We took it then through key stage 3, which is design development, where we actually realized the flooding was a problem, and we developed it right through to public information events, environmental liaison groups, producing the ES, and then eventually we went to draft orders. We managed to prevent a public inquiry because we managed to engage with all the stakeholders and remove all the objections. So we then moved on to the key stage 4, which is the statutory process. So the draft orders were issued, objection periods, ministerial decision was made to progress the scheme, went through a whole High Court challenge. So in the end of March 2020, we were ready to go. But as we all know what happened then, COVID hit us. So we were just about to embark on some ground investigation and the job stalled. We eventually got back into site to do the key stage 6 construction, and we commenced construction in spring. It was April 21. Now that actually gave us time, and one of the drawbacks to my mind, the ECI jobs, is that the design stage is missed out. So we were able to develop the design through the period where we were on hold during COVID. So when we started work on the scheme, we had design drawings, and the biggest problem was actually the biggest, not delay, but critical to the job was actually ordering and delivery of the steelwork. So we actually were able to progress that procurement of steel very early on. So we moved on to actually doing the groundwork, but there was a lot of diversions. We actually put in the piling, we carried out this summer, and then we sort of progressed through construction. We finished the push launch very well. It all went well in about 15 weeks. Very good progress on that. And then we managed to get the steelwork erected over the river before Christmas in 22. We left us last year. Then we were at a good place this time last year with all the concrete finished, and we were doing the finishings like waterproofing and all these dry weather jobs we thought were coming in the summer. It was wet in this area for 6 months from August right through to the new year, and it never stopped. So we were delayed with all that, but eventually got the bridge finished in February this year, open to traffic. So that's a view of the scheme before we started. This existing trunk road in the south here, and to the left of the picture, the old bridge. We were going to cut across that line, so we started to mark out the line of the structure. We were also starting to build the flood bund along the eco park. The ground conditions were very poor. You can see the standing water here. We had to get haul roads out to get from the road to the river, which is about 500 meters, because we had to take steelwork and all materials down to the bridge to the south of the river. So we had a compound area on this floodplain here. We did raise an area which was out of the floodplain where we had some offices and a refuge for plant. But we actually used timber matting to make the haul road, which we also then doubled up on to use for the piling platforms, and that was a bit of a success story because we just retrieved most of those now, and they're all still of some use. They were really useful, and we all know the timber floats during a flood, so we had to moor them down with ropes. But that was one of the success stories. You can see the flood bund on the right there, which runs up alongside the eco park. That was had to be done early in the job because our work was going to, cause further problems here. We were obviously then working very adjacent to the railway, and we had some interface with Network Rail to actually build our bunds into their work. So we started piling. This is the 121-ton rig here. This is a 1,200 diameter CFA continuous slide auger pile, which goes down to 28 meters. In that photograph there, you can see them. They actually plunge in the steelwork. So they bore the hole. They then put the concrete, tremmy the concrete in through this auger, withdraw the auger. They then plunge the steelwork into the pile itself. And there was 40 of those we did. We had to be very accurate with those locations because, as I said, those go up onto a 2-meter diameter reinforced concrete pier. We had to be within 25 mil with the piles because there was any eccentricity on that would cause a problem for the loading. This is where we had to do some cofferdams. The Pier 11, the middle pier, was located on a bigger foundations because the loads were heavier. So at this location, we had to put a pile cap, a reinforced pile cap, and there's a series of 750 diameter piles there. We had these on two of the columns where the loading was higher, but you can see the extent of the temporary works that were required to put these pile caps. So when we just had the monopile, we were actually saving a lot of reinforced concrete time and effort. So there again, you see the pile cap. This is the slabs are poured and the reinforcement coming up here. And this is a monopile where we broke down about 600 mil below the ground level just to found our piers. So the amount of work in these different sort of scenarios was amazing. So we started to progress. Obviously, the compound was developed. These are the timber mattings coming into our haul road. There's the flood sort of bund, pretty well complete now. This is the railway line coming across here. This is the new scheme with our flood bund going around the eco park. We had to interface with the rail embankment at this location here, which was quite close to the running rail, and that's on the sort of the western end. At the northern end, it wasn't so close because there were some old sidings had been here, so there was a bit more room here. But we did liaise with Network Rail right through the scheme. They were obviously concerned with the geotechnical influence of what we were doing, and you can see the influence lines here. So we actually did just tie into the embankments by benching in, all supervised obviously by Network Rail and approved by the geotechnical design. It all went fairly well. You can see from these photographs, hopefully there's the rail embankment. We were building up and sort of tying benching in with this sort of shape. Is 1 meter on the top, 2.5 meter side slopes, approximately 2 meters high. So it wasn't massive embankment, but we did tie into the embankment. There was no issues there. There's been no problem. Doesn't affect it really. There's the bund as well. You can see it tied into the embankment there, and then it's running parallel with the railway line and ties in at the eastern end there. Sorry, ties back in. So again, you can see the bund there. Look, it's grassed over now, so it's blended in quite well. And the south end, it comes round and ties into the running. There's the running rail there. This is McHuntler Station. Right, the north abutment. The abutments were conventional reinforced concrete structures. This one on the north was done without any piling, just a big spread footing. No real issues there, standard construction. And when we finished that, there's a finished structure there, look, so that was pretty straightforward construction. Sort of cantilever wing walls there. We then get on to the erection of the bridge itself. So these are the reinforced columns that we built. So these are all up through the job. These represent 34-meter span bridge deck units to just go over there. This work here is the temporary works for our piling platform. Sorry, our push launch platform. So we had to pile foundations because again the ground was so poor, and some of the loadings from the temporary works was quite large. We had to do pile foundations. So we got piling rigs in here, piling 600 diameter piles all through this for the foundations for the push launch. The push launch itself actually comprised these 3 slumber pairs of trestles. These were back ones, which you see in a moment. It's where you actually fabricate your steelwork, and you fabricate a couple of spans worth of ladder deck. And this one at the front here is the jacking platform where the jack is. I'll explain to you that in a bit more detail. And obviously, then you lift in your side spans and your cross members to form a ladder deck. So it looks in plan like a ladder. And this is how we did it. So there's the steelwork comes in. It's landed on stools right adjacent to the work. It becomes this crane didn't move from this location, so our steelwork was coming in from Italy. To be honest, we were laying down. They were coming in 17-meter lengths, and they were bolted together to form the 30-odd meter spans. These are the transverse sections. They were every 3.4, so it's 10 of them every span. They will erect these on these trestles, and if I go on again, they're erecting the side span there, right? Just as a matter of interest, we were working with Cleveland Bridge to develop this job early on, and as probably some of you know, I think affected the rail as well. Cleveland Bridge went into administration in May 2020. That left us in a bit of a lurch because we hadn't even ordered our steelwork. We then had to go back out to the market, and it was at the time when steelwork and all steel prices, material prices were going through the roof. We ended up placing an order with a firm called Chimeli from Italy. They were a lot cheaper than the British companies. Steelwork was, I say, almost doubling in price by now. And this steelwork was fabricated in Italy, but it actually came from Ukraine. It was actually made in Mariupol. It was delivered to Italy in January 21, I think it was, just a month before Russia invaded Ukraine. So we would like to see that, and it's not in a Russian tank somewhere. So this is the front trestles you saw from that little plan location. Here you've got your jacking system all set up. You can just see the rams of the jack there. And what happens is this clamps onto the bottom flange of the beam, and it actually pushes, but it actually pulls the beam along. So hopefully if I press that button there, you'll see it moving along. That jack has a 2-meter stroke. So it then goes back and pulls again. So every stroke is 2 meters. The span was 34 meters. And we did actually do a 34 meter in one day, but generally we were taking 2 to 3 days to push one span. And again, all the columns were set up with these roller bearings to actually let the beam roll across the top of the bearings. They were quite big. These are something like 2.5 meters long. There's also a guide at the side of them to keep this online. You can see the guides there, and we had a problem with that, to be honest, because if I just flick this one, you'll see the nose-in unit here. I hope you can all see that starting to move. It comes onto this roller bearing, kept online by this rather sort of simple guide system here. When we first started the launch, the nose-in didn't drop as much as was anticipated, so the nose-in was actually above this control. So we managed to go offline a little bit, but we jacked it back, and obviously it eventually came down. And after a little hiccup at the first push, we were managed to maintain a tolerance of within 15 mil all the way through the push. Obviously, it's been checked every day, and there's measurements on the column to check any movement. Because I say these 2 meter diameter columns up to 5 meters, 6 meters high were based on located on or performed onto a 1,200 meter pile, 20 meters in the ground. So there was potentially a lot of movement. So you can see the jacking system again, where it clamps on to the bottom flange of the beam. There's a shot looking north. You can see all the piers are in place now. They've all got a roller bearing and guide on them. And so that the push launch is going. I say we made really good progress. And what we were doing as well, because you'll see in the next slides, so this is a time lapse. So as the beam was being pushed forward, we had another team erecting precast deck units. So hopefully you can see that this was like a factory workshop here, where the crane itself set at one location, beams been delivered and dropped off right adjacent to it. A secondary crane then about 3 spans up to leave enough room for health and safety. This is the bridge deck units being laid down here, both sides of the structure. So this is the first few beams going on the trestle. That's the nose in again, you saw before. So that starts to all place now, starts to push. And as it got up a little bit further, we put these precast deck units on, and we found we could actually work. We placed them when it was obviously not being pushed, but we found we could work on that deck as it was being pushed. So the lads were able to put up the edge restraints and fix some of the steel for the stitching during the push. So it helped us along with progress. And ironically, we had some of the best weather as well through this push launch. So there you can see the beams on there, look, and the slabs on the floor ready to put the next one on. So it became a bit of a conveyor belt there. All went very slick, to be honest. So as they were erecting the beam here, we were lifting the beams on, and then we'd push and then carry on with the edge restraints and fixing steel. It didn't go quite as fast as that, but looking back on it now, it went quite well. A lot of people ask me now, would we have done it conventionally better with having cranes at every location? I don't think we've done it as quick, and we would need a lot more room because the footprint of this was quite narrow. And we had crane platforms each side and maintaining access for raw materials going down the river, we would have needed a land take of twice as much area. So I think the push launch was quite a successful choice. lot of temporary works involved, obviously, because of the ground conditions, but I hope you could all see that. I know it's finished. Is it finished, Steve? This shot here is a shot of the end of the push launch. So as we pushed up to here now, there was a connection from the ladder deck into the multi-girders, and there's a connection here with a diaphragm, but we had to support this last span. So what happened here, we stopped pushing at this location, which is pier 17 and 18. We had to lift out this nose in, so it was unbolted, lifted out, and we lift the last piece of beam in there, we lifted it in with crane. And then when we actually went on to do the multi-girder, so that's the end of the push launch looking south from the river. We've got a girder to the cross there, which is the cross girder, and then our big girders came down over the river and joined in, which is about a quarter point of that span there. So that was the end of the push launch, start of the big lifts. So there's a shot of the whole push launch. We pushed out 400 meters of bridge, about 4,000 tons there. So you've got actually roughly 400 meters of bridge deck in place. Obviously the units are in place, but they aren't stitched together. So precast yard, we chose to go precast on all the deck units for, well, obviously for quality, to avoid wet trades with the floodplain, all the environmental issues we've had. It was in a very sensitive location, this river sort of valley. We're obviously next to a high quality fishing river, a lot of water around us, high water tables. We had to do a lot of water monitoring, silt protection. We had bunds and settlement pools everywhere. So it was very high quality. We were being watched by natural resources well, sorry. We had to put fraps in for everything. So we chose the precasting option as a best solution. So these are some of the units we had made in ABM yard in Nottinghamshire. And then we lifted them on, as you saw in the video there, and we held them on temporarily as we were jacking. On the push launch, the deck unit was full depth over the river, which I'll show you in a minute. They were half depth, so we were able to save on all our temporary works for the cantilevers. So there's an in-situ pour on top of the half deck, so we had some in-situ work there. For the curved section, we had to revert to conventional because it didn't lend itself to precast units. It was curved. It was of different widths, so there were lots of bespoke units and wasn't attractive to the precast boys. So this is the beams on place, or slabs in place. Obviously, the stitch joints to go to stitch them together, and we were able to fix the steel, as I said, when it was being pushed. And at the end of the day, we did all the concrete into these stitch joints when we finished the push launch and the bridge was still. These other units fit over the shear lugs on the steel. There was a lot of thought going into this because you can see there's not a lot of room. These slabs are 250 thick. The steel is quite heavy, both faces. We've got little places to go there. So how do you get the steel between them? I'll show you this one as well. This is when things go wrong. We had problems with defective units. That's a view from the soffit of the slab over the river, where they were badly cured. We had 30 number like that, and they were cracked like through. And obviously you can see that's the water coming through them. So we had a big argument with our supplier on that one, and we eventually got them all replaced, and these were rejected totally, you know. So not all good. That's the top of the beams, I say, and these shear studs had to fit between those sockets in the. We didn't have one clash on the whole deck. We didn't have one clash of those shear studs between those, and that was credit to Arup, our steel designers, who moved these locations of these studs, and our precast suppliers to get it all right. So that was a good news story. I thought we'd be the sledgehammer banging those around, but we were quite good there. So again, you can see them. These are the stitch joints over the piers, and obviously there's going to be an edge beam as well, an L-shaped edge beam over the whole length here, stitched into this. So still quite a lot of work to do in situ fixing with the precast, but the precast itself was a very good quick solution for the decking. Again, you can see there we got the whole length pushed out. Some 400 meters of bridge there. Right, now we came to the big lifts over the river, the multi-girders. This is just a layout. There, our ladder deck, which I showed you, stops on the quarter point there. These are the beams, 4 number beams laid down, ready to lift in. Chimolai, our supplier, decided to do this with a tandem lift, which we weren't totally happy about. You normally lift big beams in like this because they're very slender as brace pairs, so they're stable. So we actually lifted these in, roughly 160 ton of weight there with those beams because they were quite long. They're 70 odd meters long. That's the two cranes, and that's the size of beam they were left in. So there we are, the 2 cranes. This is the crane you saw in the previous pictures from the bottom. There's a 350, that's a 250. It's regarded as what they call a complex lift because things can go wrong. The beams were stuck on the outside that had been maneuvered through into place. So there was a bit of thought scratching the head on that one. And obviously temporary with support. I don't think it's a bit dark, that photograph, but with the last one. So there's the last beam in place. So that was the end of the ladder deck. And that beam there, I say, is 70 odd meters long, 150, 60 ton with all the weight on it. And it all went in really well without an issue. So saved us going to put a big crane in here because we did require a massive crane here, 1,000 ton plus, which in this location would have been a nightmare because it's all in the floodplain. We had to build it all up. So we avoided all that by having these 2 mobiles, which could move quite quickly out of the floodplain if there was a flood event. We then went into north. I'll flick, sorry, I know I'm there. Are you seeing multi-photographs now? Gosh. Sorry. Must have pressed the wrong button there, sorry. So we're coming to fit the crane. When I took this picture for the slide, that's Saren's got-to-well crane, 1,200 ton weight, and that was on one of our jobs in Worcester. So there it is on a north abutment. So here we are now. You can see we just placed those beams south of the river. This is the big span across the river now, 75 meters. So we lifted these in with the brace pairs, which came in, and these are welded connections there. So you've got the beams welded together, all braced together. A total weight here of 170 ton, quite a big radius because we're well back. This crane takes nearly a week to erect. It comes with an auxiliary crane and about 28 Arctic loads of actually boom and counterweights. So this came from north of England. It actually managed to break down on the way here, but we managed to lift this in the week before Christmas. The weather wasn't too bad, so we lifted in the beams, and you can see them there on the side. The weather in Machynlleth was very nice, but suddenly it went black, rough, and this is like a big sail in the air, so we had a bit of problems trying to hold that, but we did get it placed quite well. And you can see there's the beam comes in. Behind here, you've got actually a load of boys with up on cherry pickers, and to do the bolted splice connection. So again, that was another milestone for us. That's the second beam going in actually. So there where the beams are completed over the river. We then went back to the curve section. So this was the start of this piece here was the ladder deck we'd already placed as part of the push launch. We'd removed all the temporary platforms now from the push launch. We now started to construct the curve section from this location back to the abutment. You can see it's curved, it varies in width. So we had to have cranes at every span here, which is say we saved doing that on the main run because we pushed it all from one location. So here we built conventionally, put the side spans in, transverse spans in, right back 5 spans going back through, getting closer. You can see the cross fall now in the steelwork. You can actually see the verge kinks, and that's why the precast manufacturers weren't interested in this. It was too complex. That's a shot of it. So there we are. That's the whole steelwork finished now with the profile of the steel there ready for the deck. Because we're going to go in situ now, we had to put sort of permanent formwork between these beams. We have to do the paraslims to get the cantilevers. So we're back to more work. Obviously, we saved all that when we used precast units. So there's a diaphragm at the abutments. There was diaphragms across to hold all the beams together. So there we are. That's the whole bridge now. So we've got the push section in the middle. We've now placed the beams north. We've now finished all the steelwork on the south. This is the permanent formwork going in. and we were on at the top here as well. I think we were delayed up here with those replacing those precast units. That held us up about 3 months because we intended to come in from the north, and because that was held up because of those units, we had to wait till this was finished to get access on the deck. So that's the north section advanced now as well with all the beams on. And there's a narrow, a thin section of reinforced concrete to go on top of that, because we got the half deck, so we've got all the soffit covered and supported. That's the approach from the south. Another shot looking down it now. So we're starting to put some curbs in there, but as I said earlier, we were at a good place in August last year. We thought we were going to get some dry weather to do all the finishings, all the waterproofing, and it rained, I think, from August right through till, well, last month really. So it's been very wet and been slow progress. So all the finishings took a time. So the parapets are on. I think we put in the drainage curbs in the that's the last pour on the north there now as well. So you can see the scale now of the structure. You can see the height, the embankment up here as well. The height out of the river, we're about 3 meters above the field level here. This was our compound area. And I say that's the full Dyfi Valley there, which floods. I'm aware that I'm probably running over a bit, you know. So there's finishings, there's the waterproofing on, surfacing work on the approaches. One thing we had to do, because we'd jacked this and we had the temporary bearings, you saw the roller bearings. Those roller bearings were quite high off the top of the plinth, about 600 mil. We need to jack them down now to actually put in the permanent bearings. So we had to jack these down. So they were 600 mil jacked down. So we had to do it in 200 mil increments. And that was a job that took us longer than anticipated because there were so many spans and we had to do it in 200 mil increments starting from the middle. It required a lot of jacks and a lot of temporary work. So it took us nearly 3 weeks to jack the bridge down onto its permanent bearings, which here they are. We have to do the bearing plates, the sort of set underneath. These bearings had to be set in the evening when there was the least amount of temperature movement. We did have a problem with one where the steel had obviously warmed up in the day and it cooled and moved down at night, resulting in some issues with the bedding mortar. But luckily, again, it all went fairly well. Just general construction there. So your deck construction's ongoing above. Just concrete pours with pumps. That's your waterproofing. The waterproofing was 3 systems with primer, a first coat and a second coat, and then you put a tack coat on top prior to your surfacing. Infill in the verges where the curbs are in. This is the joint. The bridge is 724 meters long. There's a fixed joint in the middle, pier 11, and the movement each end. This movement joint is quite big. It's a modular joint. Again, we had a slight delay with this because, like everything else, we don't make anything in this country, unfortunately. It was coming from Spain. There was all sorts of issues with fabrication, with their shutdowns and everything. So we were late getting that back. We should have been in before Christmas, and then eventually it arrived in January. So we managed to get it finished and open beginning of February. And that takes up movement up to nearly 300 mil. Again, a few finishments. This is approaching the approach embankments, finishing off footways and things generally. Usual finishings, footways, street lighting, the like. Surfacing, we did some with tarmac construction. We're part of tarmac, and as you may know, but we did it with our own surfacing gang. Flooding during construction. This is why we were there, and this is the valley in full flood. Here we are with the bridge up in the air, but this is Pier 19 by the river. We had a cofferdam there. We had a temporary refuge we built. All the Nobel plant was pushed up there. So we had disruption, obviously, but we had no damage to permanent damage. Our temporary works were affected because the water came through us, but we managed to control all the plant by getting it up to high level. We'd have a warning. We used to watch the river levels, and we had a level on the gauge of 3 meters. If it was over there and rising, we'd pull out. And we were lucky in the first year or so, but we have had a few events this year over the winter, a couple of events, but nothing major really. We managed to cope with the flooding. You can see the area there where the bridge is going on. But this is the worst thing we had. The local authority would close the road, and they were always late. and people were desperate to get through the flood and would try and negotiate the flood water. And this lorry was there from 2 o'clock in the morning, rested where the fire brigade. He nearly tipped his wagon over. This is the mess we had on the road when we had all the temporary works, barriers, everything moved, and the scour we had of our verges, because although not terribly deep, the water's quite fast flowing and aggressive. So, and there's some more flooding shots there. So you can see, so we dealt with that, we finished it. So now the people can get over the bridge. So there's the finished job, open to traffic, been fairly well received. So obviously the resilience is back when you're traveling this route, and you can come through in flooding. This road here has been detrunked into just a private means of access, and stops at the bridge. And the other one's gone back to Gwynedd Council, which is back to 493. So that's about me. Finished another shot of the bridge from the north. That's the junction going back to the 493 to Abu Dhabi and points west. There's the million-foot bridge. We maintained. There's a footway comes up through here. Cycleway comes up through here. We managed to control that with the banksman and didn't have to close it. We controlled it with the gates. So we maintained it. It's quite well used by the locals. So we didn't even close that during construction. And there's the team. So that's me finished. I won't run over too much. All very condensed, sorry, but I hope it was of interest. It's been a lovely scheme to work on. I was lucky enough to be involved early on, bringing it through the ECI, the environmental stage, developing the design, working with a very good team from Arup going forward. So I think it's been an enjoyable scheme and hopefully some interest to yourselves. So that's me finished. If you want to ask some questions, or shall I stop sharing?
Yeah, thanks, Julian. I think Peter's dropped off now. He had to go to another engagement. So
no, that's fine. Yeah.
Thanks very much for your presentation. I certainly found that really interesting, quite fascinating, actually. So I'll just invite the members of the audience to field any questions. You can either type your question in the chat box, or feel free to unmute your microphone and ask your question. So yeah, have we got any questions from anybody? I've got a couple, but I'll invite the audience first. Anybody? No. Okay. I'll ask you my first question, Julian. I was looking at the Google Maps earlier because I wasn't familiar with where the River Dyfi is, and I'm interested to see it. Seems like it forms the southern boundary of Snowdonia National Park. So I was wondering, did that provide you with any constraints on this scheme, working within or near to the national park?
Yes, they were. I rushed over a lot of this, right? During the ECI process, there's massive stakeholder engagement, and Snowdonia National Park were one of those, along with the Natural Resources Wales, Namutra, local authorities, Welsh Government, obviously. All the stats were engaged because there was massive stats diversions here. But Snowdonia, the only one input they had, if we went back, just go back one slide, people were concerned about this junction here. That's a dedicated right turning lane, which takes the traffic coming north and west back to Abu Dhabi. Everyone did a roundabout there, and on a safety basis, because perhaps you don't know the area very well, but when the time we were starting this, they were retrofitting 2 roundabouts on the Dolgellau bypass, the A487, which was a political decision, not an engineering decision. It was the road users who were causing the accidents, but they were retrofitting them up there, and then the local community here were concerned that we were going to put a junction here, wait for some accidents, and then build a roundabout. And why do we have a roundabout on day one? National Parks told us, because you have to light the roundabout. If we put a roundabout there, they would object to the scheme. So that was one of their major inputs into the scheme, was a red threatening to object. But obviously, we didn't go for that. We went for this junction, so didn't do. But it was on the end of the actual boundary is halfway across this field, apparently. I don't know why it's there, but we didn't have a lot more problem with them. They wanted a gateway feature to actually come back into, as you tell people to come into Snowdonia. Personally, I don't think you need that, because if you see the view coming up there, it's amazing, because you can see the Davies Valley and Dulles Valley. That's your welcome to Snowdonia, because it's a beautiful view, as going south is looking down the valley. So they weren't too much trouble, really, apart from the roundabout issue.
Right, thanks. Yeah, and lastly, the other question I had, well, I have, although I'm a permanent way engineer for most of my career, I have done a short stint in drainage and highways as well. So just thinking back to that experience in projects similar to this in the floodplain, I remember there was the Environment Agency were quite hot on making us provide flood storage compensation where we're building within the floodplain. So I was just wondering if you had any considerations like that. And also, was there anything that dictated the final highway level? Did you have to design that to be above a certain flood return period level, for example?
Yes. Again, I jumped over all that because it's designed for 100-year plus climate change and a freeboard. So there's underneath this lowest beam, and this last beam here was actually slightly shallower to maintain that, because the other critical thing was getting this just south of here is the railway bridge, and you had to get under the railway bridge. So the vertical alignment was quite key to not to have this, sort of departures or on the road alignment itself, the horizontal alignment, if you like, and the vertical alignment. So that was key. And from underneath, we had to reduce the beam depth, if you like, to maintain the water level. So it is quite low at this end here. I say it's less than 3 meters actually. The drainage runs south off this bridge in drainage channels. It drops into the abutment there, and it comes through a channel back to the river. Underneath here, it's not an attenuation pond as such, but there's a pond in here which is designed really to deal with any, should there be an accident on the river and a spill, and there's a shut-off valve on that. So that's the only attenuation they've got to protect the river from any sort of fuel spills. Because you're in the floodplain, there's no location to put that,
Yeah, that's great. So I'll just ask one more time in case anybody's decided, thought of a question while I've been asking you my two. So just last call if there's any more questions anybody would like to ask Julian before we wrap up. No, I think looks like we're all done, Julian. So once again, thanks very much. I found that a fascinating talk. I hope it appealed just as much to the rest of the members and people joining in the audience. Although it's not specifically railway, I think it's still very, very relevant to the kind of work we do as railway infrastructure engineers, because we at the end of the day, we both deal with designing and building infrastructure in long, linear, narrow transport corridors, which run through urban and rural areas, and in this case, bridging over considerable constraints such as the floodplain. So, that's all the kind of stuff that we are used to doing on the railway as well. So, yeah, really interesting. And also, we are the Cheshire and North Wales section, and we do like to provide a fair balance of projects within North Wales and Cheshire or Northwest England. And although you did say it was mid Wales, I think it is bounding on the southern edge of Snowdonia, so I think that more than ticks the box for providing a bit of interest for people from the North Wales area within the section as well. So thanks very much.
It could have become a much bigger scheme if we'd done a bypass or gone on the railway, because just south of here we've connected into a low height railway bridge.
Yeah.
For those of you who may know, Machynlleth Station actually goes over the bridge. The platform extends over the bridge, so it's a shame we couldn't have somehow made more clearance on the bridge or raised the railway there. So.
Yeah, well, you provided a bit of benefit to the railway with the bund you put there as well, I guess. So,
yeah,
I'm assuming that. Apologies if I missed it when you're talking about that, but that's a permanent feature, is it? That will stay there.
Yes, that bund. It's the photo I got then. It comes down that sort of northern edge of the bund. It runs into our embankment and extends on again here to tie in with the railway. So everything in there is protected. In fact, there's a secondary thing. Any water that gets in, because I showed you a couple of shots of it flooded on the railway as well.
Yeah.
That's trapped water, if you like. It's not fluvial, it's not river flow. It's where it comes through the railway embankment and off the road. So there's a pumping station in there. I couldn't cover all that, sorry, in this talk, but there's a pumping station located inside there as well. So there's twofold. There's the flood in the valley and the flooding under the railway bridge. But we were dealing with both solutions at this time, So yeah, that's obviously because you've got a rail depot there and access to your maintenance north of the river, so that's giving you full-time access to that.
Right. Apologies, very rude of me. I meant to switch my camera on when I started to do the wrap-up session. So I've just done that. Yeah. So so thanks once again, Julian. I will mention actually before I finish rattling on. Julian did step in at very short notice, relatively short notice, to provide us with this talk. So yeah, that's really much appreciated, because we did manage to fill this last slot of our summer calendar. So that's really good, and it turned out to be a really interesting presentation as well. So yeah, just lastly, I will invite members of the audience to show our appreciation to Julian. So you can either unmute your microphones and have a round of applause, or alternatively, if you click your React emoji or icon at the top of the screen there, you can do a virtual round of applause.